Okay, this is section 6.6, and we're going to use the properties of the logarithms that we just did in 6.5 to solve types of equations where the variable is an exponent. So remember, the logarithmic function to the base a, where a is greater than 0 but not equal to 1, is denoted by y equals log base a of x, and is defined by same definition we've had, log base a of x equals y if and only if, sometimes mathematicians abbreviate if and only if with IFF, a to the y equals x. And remember, the domain for the logarithmic function is 0 to positive infinity. Okay, here's a rundown of the log properties again. We wrote those at least twice in the last lecture, so I'm not going to go through them again. So what is the strategy for solving logarithmic equations algebraically? Well, we rewrite the equation using the properties of logarithms so that it's either log base a of x equals a number, or log base a of something equals log base a of something else. If the equation is of the form log base a of x equals c, we change it to exponential form to undo the logarithm, and then we solve for x. If the equation is of the form log base a equals of something equals log base a of something else, we can use property 9, it says 8, but they mean 9, to get rid of the logarithms and solve. Okay, always remember to check your solutions, because sometimes we'll get solutions that are outside the domain. Remember, the argument of a logarithmic function has to be greater than or equal to 0, or we get an error. So let's practice some of these. Alright, on A we have log base 3 of 4 equals 2 times log base 3 of x. So we are going to rewrite that as soon as I figure out where the cursor went. There it is. As log base 3 of 4 equals log base 3 of x. Remember, we can move this 2 from the front up to the exponent. So now the logs are the same, which means the two arguments have to be equal. So 4 has to equal x squared. And then using the square root property, we square root both sides, and we get plus or minus 2 equals x. However, if we go back to our original equation, where we have 2 log base 3 of x, x has to be greater than 0. So that means throw out the solution x equals -2, because x has to be greater than 0. So our only solution is 2. And we write the solution in set notation. Now for the next one, we have log base 2 of x plus 2 plus log base 2 of 1 minus x equals 1. So we need to combine these into one logarithm using the property that when we have a sum, we can turn it into a product. Now we can use the definition, change it into exponential form. In other words, it says 2 to the first equals x plus 2 times 1 minus x, and then we FOIL, so we get x minus x squared plus 2 minus 2x. So 2 equals negative x squared minus x plus 2, or x squared plus x equals 0. And if we factor, x equals 0 or negative 1. Now, we have to check our answers to make sure that we don't get a negative in an argument in our original equation. So if we put 0 in for x, we get 2 in the first logarithm, and we get 1 in the second logarithm. So we're good. If we put in negative 1 in the first logarithm, we get positive 1. And if we put in negative 1 in the second logarithm, we get 2. So we're still good. So our solution set is negative 1 and 0. Okay, what about logarithmic equations like in example 2 here? Well, in part A, on the left-hand side, we're again going to have to change it into a single logarithm that's a product. So we have x times x plus 1 equals the natural log of x plus 2. So again, these are logarithms with the same base, e, so we just set the arguments equal. So x times x plus 1 equals x plus 2. Now we multiply, so we have x squared plus x equals x plus 2. Now I've botched again. This should be a minus 1, which makes this a minus 1, and this a minus x. So that's x squared minus 2x minus 2 equals 0. Now, unfortunately, that doesn't factor. So we have to use the quadratic formula. You guys can work this out on your own, but we should get that x equals 1 plus or minus the square root of 3. Again, we must check answers. So, if you plug in 1 plus the square root of 3, then all of our arguments are okay. They're all greater than 0, so we're fine. If we plug in 1 minus the square root of 3, unfortunately 1 minus the square root of 3 is a negative number, so we would be trying to take the natural log of a negative number here in this log of x term. So our solution set is just 1 plus square root of 3. And that's because 1 minus the square root of 3 is less than 0. So not in domain of the natural log of x. Okay, on part B, since this is a difference, we need to change it to a quotient. So we have h plus 3 over 2 minus h is 1. Now applying the definition of logarithm, 4 to the first power is h plus 3 over 2 minus h. So essentially the 4 is over 1 and we're cross multiplying. So we have 4 times 2 minus h equals 1 times h plus 3. So 8 minus 4h equals h plus 3, which means 5 equals 5h, or h equals 1. Again, check, and we find that we're good, because 1 plus 3 is 4, that's greater than 0. 2 minus 1 is 1, which is greater than 0. So our solution set is 1. So moving on to the next page. We have the log of 1 minus c equals 1 plus the log of 1 plus c. So first we need to get the logarithms on the same side of the equation. So we will have log 1 minus c minus log 1 plus c equals 1. Okay, now we have a difference, so we change that into the log of a quotient, 1 minus c over 1 plus c equals 1. Now remember, when there's no written base but it says log, that means that the base is 10. So 10 to the 1 equals 1 minus c over 1 plus c. And now we're cross multiplying again. So 10 times 1 plus c equals 1 times 1 minus c. So 10 plus 10c equals 1 minus c, or 9 equals negative 11c. So negative 9 elevenths equals c. Again, check in the original equation to make sure we have no arguments that end up being negative. 1 plus a negative 9 elevenths is greater than 1. 1 minus 9 elevenths is 2 elevenths, so we are positive. So our solution set is negative 9 elevenths. Moving on to D. Again, we need to get the logarithms on the same side. So the log of 3m plus 1 minus the natural log of m minus 3 equals 2. So, making a quotient, the natural log of 3m plus 1 over m minus 3 equals 2. Natural log means base e, so e squared equals 3m plus 1 over m minus 3. Cross multiplying, we have e squared times m minus 3 equals 3m plus 1. E squared is just a constant. Don't let it scare you. So we have m times e squared minus 3e squared equals 3m plus 1. Now get the m's on one side of the equation. So we have m times e squared minus 3m. I move the 3m to the left side. I'm going to move the 3e squared from the left to the right, so it becomes positive 3e squared plus 1. Now, to solve for m, we have to factor out the m. So we have e squared minus 3 equals 3e squared plus 1. So m equals 3e squared plus 1 over e squared minus 3. If you put this in the calculator and then check it, you will find that it is a valid solution, and I'm not going to write it in set notation just because I'm lazy. Okay, on part E, since we have a log equals a log and they have the same base, that makes life a little bit easier. So log base 9 of x, remember we're going to move this coefficient up as an exponent, and we're going to do the same thing. Remember, this is a -1 coefficient, so that makes an 81 to the -1. So we have x squared equals 81 to the -1. So x squared equals 1 over 81. And if we square root both sides, we find that x equals plus or minus 1/9. But go back to our original equation. We have a logarithm of a plain old x. So x cannot be 1/9. So our, -1/9. So our solution is positive 1/9. X cannot equal -1/9 because outside the domain. Okay, and the last page. Okay, we have three to the x equals 7. So we can take the natural log of both sides and go from there. So the natural log of 3 to the x equals the natural log of 7. Using the rule for the exponents, we can bring the x down in front. So x times the natural log of 3 equals the natural log of 7. And then we just solve for x. So we get the natural log of 7 over the natural log of 3. In part B, it's essentially the same thing, but we have to move the 5 to the other side of the equation first. So we have 2 to the x equals 3 over 5, which means that the natural log of 2 to the x equals the natural log of 3/5. So, using the exponent rule again, sorry guys, I keep hitting the wrong button with my hand. So, using the exponent rule again, we have x natural log of 2. Now remember, this is a quotient, so we can break it up into a difference. So natural log of 3 minus natural log of 5. And then solving for x, we have natural log of 3 minus natural log of 5 over the natural log of 2. Okay, part C. Again, just taking the natural log of both sides. So natural log of 2 to the x minus 1 equals the natural log of 5 to the 2x plus 3. And we are going to move the exponents down in front as always. Whoops, that's a natural log of 2. Sorry. Natural log equals 2x plus 3 times the natural log of 5. Now we have to distribute, so we get x natural log of 2 minus the natural log of 2 equals 2x natural log of 5 plus 3 natural log of 5. Get the x terms on one side of the equation, so x natural log of 2 minus 2x natural log of 5 equals 3 times the natural log of 5 plus the natural log of 2. Factor out an x on the left-hand side. We get natural log of 2 minus 2 natural log of 5 equals 3 natural log of 5 plus natural log of 2, which means that x equals 3 natural log of 5 plus the natural log of 2 over the natural log of 2 minus 2 times the natural log of 5. Okay, the last one. So for the last one, this is a little bit different. So you see we have a 3 to the x here, and we have a 9. We know that 9 is 3 squared. So if we make that a 3x whole thing squared minus 3 to the x minus 6. Now, we have an equation that is quadratic in form, so we're going to substitute. Let u equal 3 to the x. So what we have is u squared minus u minus 6 equals 0. So u minus 3 times u plus 2 equals 0. So u equals 3, or u equals negative 2. Now we have to go back in and substitute for u. Remember, u was 3 to the x power. So 3 to the x power equals 3, which means that x has to equal 1, or 3 to the x power equals negative 2. But we're going to throw this one away, because a positive number raised to an exponent cannot be a negative number. So there's no way that equation can happen. So our final answer is that x equals 1. So that's the end of 6.6.